Hi everyone, welcome back. Well, we're down the road at the neighbour's place today, and I just thought I would take this opportunity to talk about different ways of getting hot water when you're living off-grid. This little Nissan hut is the first place that I moved into when I moved out of home, and I lived here for quite a number of years. Obviously no one's lived here for a long time now, and I really enjoyed myself in the Nissan hut here. One of the problems though is it was pretty basic. So there was, when I initially moved here, there was no power, no water, and not much other than just a roof over your head. I'll take you inside and show you the little hot water system that was here. So the poor old hut's looking a little bit the worse for wear now, but if we come into the bathroom here, it had a shower and a lovely big bath. One of the things I thought was always curious about this place is all of the power points, and there's very few of them in here, but they are all 15 amp power outlets rather than the usual 10 amp. So I always thought that was a bit strange. Anyway, if we come in here around behind the bathroom door, there's this little chip heater here, and this is amazing. You can get hot water out of it with about 2 sheets of newspaper in here. It's got a really small firebox down here, and you have to sit next to it and keep an eye on it the whole time. It took about 45 minutes to fill the bath up, but you could get it hot enough to cook somebody in without any trouble at all. So this system here is a non-pressurized system. There's a tap here, water line in, the water goes in the bottom, and there's a pipe out the back here that runs down. It's broken off now, but it runs down into the bath. There's also an opening up the very top here, so if it boils or anything, it sprays water out the top here. Inside here there's 2 sheets of copper with a gap about that big between them. That's your water jacket. Everything else inside there is taking the heat out of the fire. This was really efficient, but it did only fill the bath up. If you wanted a shower, there was a cold tap only. And when I moved up here, I decided that actually I wanted to be able to have a hot shower a bit more easily. So I put in I ran hot water all through here. We'll go up on the roof now and have a quick look at the hot water system that I built. So this is the hot water system that I built, and obviously the tree's grown up a fair bit more because it used to be in the sun at this time of day. Obviously it's in the shade now. Now this is a fairly standard solar hot water system. Got this panel for free. I actually made this out of 3 different panels. The tank is just a normal electric storage heater tank. I used that because I got that for free as well. I even got most of the copper pipe free. And this worked really well. Any day that you didn't need your jumper on for most of the day, you got enough hot water to have a hot shower when you got home. And that was a lovely luxury up here. Here we are in the kitchen now, and we put in a gas stove for cooking through summer, and we had a wood stove for cooking through winter. Now, any day that you needed your jumper on for most of the day, you didn't get hot water. So this wood stove here has a wetback in it, with water pipes down here. They go inside and heat your water for you. Now these old Everhots were great stoves in their day. These are a slow combustion stove, so they're designed to be going all day. You light it first thing in the morning when you get up, and you keep it going all day, and you light it up before you go to bed at night. They're quite well insulated, so they don't heat the room particularly well. But one of the great things about these is the oven door opens sideways, which means you can stand in with your legs in the oven and close the door halfway across your legs, and that was a great way to keep warm. One of the problems with this one being a slow combustion stove was, because it was meant to be going all day, it heated the water fairly slowly. Because I wasn't here all day, I'd sort of get home at 7 o'clock at night and light the stove to try and get some hot water, and with a roaring fire in there, you'd get warm water after about an hour. You could go and have a shower, which meant it was fairly late nights for me often by the time I got home, and had lit the fire and managed to get a warm shower, and I was certainly ready for bed by the end of all of that. But this system worked well enough for quite a long time. So when we moved in here where we're currently living, I decided that I wanted a hot water system that meant I didn't have to come home and light the fire at night when I got home. Now, we live off-grid here. We have no mains power connection at all, so we needed a hot water system that would work without mains power. What we ended up using was a 125 litre electric storage hot water system that is directly coupled to photovoltaic panels. These are our solar panels here. Now, these are all second-hand household solar panels, and you can pick them up relatively cheap on any one of the marketplaces. It's late in the afternoon now, so they're all in the shade a little bit, but they get good sun most of the day. So this first row of panels here is what runs the house: lights, fridge, all of that sort of stuff. This second row here runs the reverse cycle air conditioning. We have a direct DC air conditioner, so it hooks straight into the solar panels without needing an inverter or anything. This is far more panels than it needs to run in good sun, but with this many panels it means we get good heating from it in winter when there's a bit of cloud and stuff like that. This last set of panels back here are the panels that run the hot water. So what have I done to modify the hot water system so that it will run directly off photovoltaic solar panels? Well, the biggest modification to the actual drum of water is that I changed the original 3 kilowatt element out of it for a 2.4 kilowatt element. This means it heats the water a bit more slowly, but it also gives us, it means you need less solar panels. Now, these are designed to be easily changed. They're in under this cover here. There's 4 bolts that you undo. Make sure your power is off. If you don't know about electricity, probably this is not a good thing to be messing with, because we are dealing with enough voltage to kill you very easily. So if you don't know what you're doing, get an electrician to help you do this. But basically, take out the 4 bolts, pull it out. This is actually a 3.6 kilowatt element, not a 3 kilowatt. And I just decided that was too much power to try and run with the solar panels. I'd need too many panels for it. If you've got a big family and you need a lot of hot water, you can scale up the number of panels you've got to be able to run an element this size. You can get elements of a lot of different sizes to match whatever your requirements are. I went with a 2.4 kilowatt because that was what I felt I could manage with the solar panels. The other thing is that solar panels produce DC power, not alternating current, like these are meant to run on. So the thermostat that is in here will not work with the DC current. There's just too much current on it, and it ends up working like an arc welder and just burns them apart the first time they open. So we ended up putting a relay arrangement on that, so the thermostat in here only has a very small amount of current going through it. Now, I have only recently moved this into its current position, so there's still a few things I have to do to finish it off. These are not well insulated, so it's always worth building a box around them with a bit of insulation to keep the water warmer. We lose a lot of heat out of this one just sitting out like this, and in winter overnight we lose a lot of the heat, which means the solar panels are working a lot harder next day to bring it back up to temperature. At the moment I have a 12-volt battery sitting here to run the solid state relay for the thermostat. I do have a little solar panel which will go on the roof to run that, but an old dead car battery will run the solid state relays for close to 18 months before you need to charge them up again. If we come down here to our electrical box, open this up, this is the solid state relay in here. I've got the covers off at the moment. These are fantastic. I'll put a link on eBay to for all of these parts so you can find them. I used to have this screwed to the outside of the hot water system, and I melted 2 of them. Now I've got it on an aluminium heat sink, and we'll wait and see whether this one lasts better than before. We also have a circuit breaker in here, which should trip out if there's any major issues, but it also means you can switch it on and off when you need to. Okay, so how many panels do you actually need to heat your water? So we've got 8 panels here that are 200 watts each. They're 37 volt panels. These are household panels. So we have 2 sets of 4 panels here connected in series, which by the time they've got a load on them gives us about 148 volts from each set of 4 panels. And then we've got 2 sets of the 2 sets running in parallel to double the amperage to give us 10 amps at 145 volts. This gives us, there's only 2 of us here. When there's 3 of us or 4 of us, that still seems to give us a full tank of hot water every day with showers and washing up and that sort of thing. In winter, when we have a week of really cloudy weather, we do struggle to get enough hot water sometimes. I think last year that happened once, where the water was getting a little bit cold when we were showering. Once I build the box around the hot water system, that will give us more insulation, and will keep the water at a higher temperature overnight, so that it won't need to work as hard to raise the temperature in the morning. Okay, so there's a little bit of maths that we need to know about to make sure that we don't just end up short-circuiting our solar panels and in the long term wrecking the solar panels. We're using a 2400 watt element, or a 2.4 kilowatt element in here, which has a resistance of 24 ohms. You can look this up on the internet, and you'll find resistances for different wattage elements. I started out looking at using 4 panels, which was going to give us 145 volts. So to make sure that the 4 panels are going to give us enough amperage, we can, or to work out how much amperage we are going to be needing, we take our 145 volts divided by our 24 ohms. Our requirement is 6 amps. Now, our panels put out 5.4 amps. So I decided that this was not going to be enough, which is why I put the extra 4 panels on to give me the 10 amps that we are currently getting. This also gives us a bit of leeway on cloudy days. We're going to have enough power to run it for a while. Now, the other numbers we might be interested in knowing are at 145 volts times our 6 amps gives us 870 watts of heating. Now, as you change any of these numbers, you can change your outcomes. So if I put another panel on there in each string and increase the voltage, we are going to change the amperage we require. So as the voltage goes up, we are also going to need more amps. I could probably put another panel on here because I've got 4 amps spare at this point, and that will heat my water faster. So depending on your hot water requirements, if you just run through the maths, you can work out if you want 2 sets of 5 panels, so 10 panels with a higher voltage, whether that will, and depending on what the wattage of your panels are, whether or not you've got enough amps from that not to burn out your panels. You can connect your panels however you like, but you may end up shorting your panels and wrecking your panels in the long run. Okay, so what is the actual circuit that we have here? We've got our solar panels over here that come through the high voltage side of the solid state relay and then go through the water heater and back to the panels. On the low voltage side here, I'm using a 12 volt battery in this scenario, but you can use a little solar panel or something. We've got our thermostat here, which is in the heater, and it's just a temperature sensitive switch, and then that goes to our low voltage side of the relay, so that when the thermostat closes, our relay, it energizes the magnet in our relay, it pulls the other half of the relay shut to run power through to our hot water. And then this just returns to the battery on the other side here. It really is quite simple. It's quite a simple circuit. There's no particular magic in it. It just takes a little bit to nut out as you're wiring everything up. Now, depending on where you are, there are all sorts of different regulations for hot water and for electrical components. So if you don't know what you're doing, please get the help of a plumber and an electrician. The safety valves on the hot water systems are really important. This particular one does 2 different jobs. If the tank has too much pressure in it, this will release and stop the tank blowing up. But also, this one is temperature sensitive. So if your water in the tank gets too hot because your thermostat has stuck or something like that, this will open and allow the water to drain out and cold water to come in before you start boiling your tank. These are very dangerous if they boil because they can explode. There's also regulations about what sort of input taps, what sort of pressure relief valves you need, and that sort of thing. Also, when you're doing this, make sure that you earth the tank with an earth wire, just in case the tank becomes live, the same as if you had it hooked up to mains power. You want it earthed, and so there's a few safety things that you do just need to watch out for. So we've actually been using this system for about 6 years now, and other than the solid state relays getting a bit hot and having issues before I put them on that aluminium heat sink, it's been very low maintenance and we've had very little trouble with it. So this is just another idea as to how you can get hot water if you're living off grid. We get hot water as long as there's a bit of sun. We get hot water, not like the old system where it needed to be a nice warm day to give us enough hot water. This one works even if you're wearing 2 jumpers. As long as you get some sun, you get hot water. Anyway, I hope you found this interesting. Thanks very much for watching, and I hope to see you again next time. Bye!